Okay, moving into the next section. We're entering a unit on functions. So first thing we got to get our mind wrapped around is what exactly is a function. So one way to think about a function is that it's a magic box that turns numbers into other numbers. So we've got a box here. I don't know if it's magic, but it's a box. So let's put some numbers into it and see what we get out of it. Like let's say I put a 1 into it. Alright, I get a 1 out of it. Say I put a negative 1 into it. Still get a 1 out of it. Okay. Alright, let's put, I don't know, a 2 into it. And out pops a 4. We have a pretty good idea of what's happening in here. It seems like it's just squaring the numbers that we put in there. Alright, so we got a hunch. Let's try it. Alright, one more. Let's see if it works. Suppose I put in a pi. Let's see what it gives me. And there's a pi squared. So all a function is a way to associate an input to exactly one output. Alright, so there are a number of ways we can specify what a function is. Some of these you've seen before. Probably the most familiar kind is a formula. Like if I write down f of x equals x squared, what does that tell you? It tells you if I put in a number x, it's going to spit out a number which is the square of that number, right? So if I make a little table here, it says if I plug in, say, x equals 2, I'm going to get 4. If I plug in x equals 5, I'm going to get 25. If I plug in x equals negative 1, I'm going to get 1, and so on, right? So it's a way of associating an input to an output. Alright, another way you can specify these things is with a table, like we've got up here. If I just tell you, here's what my numbers are, say x is 1, 2, 3, 4, or 5. If I say f of 1 is 5, f of 2 is 4, f of 3 is 3, f of 4 is 2, and f of 5 is 1, you can just specify it like that. You could also say that for x being 1 through 5, it looks like f of x is just going to be what? 6 minus x, right? Because 6 minus 1 is 5, 6 minus 2 is 4, and so on. So far nothing new. We can also give these to you as a diagram, which is essentially the same kind of thing. I could write a bunch of numbers like 1, 3, 5, 7, and 9, and let's put them in kind of a cloud here. Let's say I've got 1, 2, 3, and 6, and I could just draw some arrows here. Say I've got 1 going to 1, 3 going to 3, 5 going to 2, 7 also going to 3, and 9 going to 6. Now you notice we got 2 arrows going to 3. Now that's perfectly alright. This just tells us that f of 1 is 1, f of 3 is 3, f of 5 is 2, f of 7 is also 3, and f of 9 is 6. Now the thing that we can't allow is the situation where we've got 2 arrows coming out of one number. So something that's not allowed would be if we had, say, 1, 2, and 3 over here, 1, 2, 3, and 4 over here, and let's say we had 2 arrows coming out of 1. Something like this. So you can clearly say that f of 2 is 2 and f of 3 is 4, but what is f of 1? The problem is, it could be 1, and it could be 3. And we don't have any good way to decide between the two. So anytime you're faced with some place where you have to make a choice, what you have is not going to be a function. So this is a relationship between a set of numbers and another set of numbers, but it's not a function. So one of the other things that we want to do is figure out, if I'm given one of these relationships, how do I tell if it's a function or not? All right, so suppose I'm given this table. Can you see why this is not going to be a function? The problem is these two rows, right? F of 1 can't be both 2 and 9. However, if I wrote down this table, then what I have is actually a function, right? Because I do have two rows that start with 1, but they've got the same information in them. So it's no problem. Here, each input is associated to exactly 1 output. So every input's got to have a function value. You can't just have something on the left that doesn't have any value associated with it. And you can't have two values associated with the same one.